All right, so 10.4 is going to be, it's about choosing appropriate measures. So if we are going to measure statistically, like this, the measures of center and the measures of variation, there are better and worse choices to use in order to answer statistically, okay? The vocabulary is going to be important. If you are asked to find a measure of center, we're talking about either mean or median. So mean is one measure of center. It's also called the average. The median is just the middle number, right? When we line them up from least to greatest, find the number in the middle. That's the median. So if you're asked to find the appropriate measure of center, you're finding either the mean or the median. So a measure of center and a measure of variation. So measures of variation tell us how much the numbers are spread out from that measure of center. So the MAD, the mean absolute deviation, is a measure of variation. And the IQR, the interquartile range, is also a measure of variation. Okay, so the vocab's important: measures of center, measures of variation. We can use these to describe data distribution. That's what we've been doing all chapter. Using the mean, using the median, using the MAD, using the IQR, the range, the mode, right? All those things. But there are more appropriate measures to use with certain types of distribution and less appropriate types to use. So if the data is symmetric, so if it is distributed symmetrically, right? And remember what that looks like. It kind of goes like, you know, it goes kind of up toward the highest number and then goes down, or it's symmetrically distributed on both sides of a low. So if the data is symmetric, if we can see the distribution and it is a symmetric distribution, then we're going to use the mean and the mean absolute deviation to talk about the data. That is the best, most appropriate measure. If it's symmetric, we'll talk about the mean and we'll talk about the mean absolute deviation. Those pair together. If you're using the mean, then we use mean absolute deviation. Remember, the mean is a measure of center and MAD is a measure of variation. If the data is skewed, so if the data is skewed, meaning remember how skewed data has a tail, right, on either side. So something like this. That would be skewed which way? Right. Skewed right, because the tail's going to the right. If the data is skewed and we want to describe the data using a measure of center and variation, we're not going to use mean and MAD. We're going to use median and interquartile range. So the first step is always to look at the distribution of the data, and then we can decide which measures of center and variation we're going to use. For example, this table shows the number of states that border each U.S. state. So it's taking a state, and then the frequency shows how many states does that state have bordering it. Okay? So it's showing how many border states every state has in the U.S. Now, here's what it says. What are the most appropriate measures of center and variation to describe the data? So here's what I would do first, is just sketch a little histogram. It doesn't have to be perfect, but it'll help me visualize the data. So let's go by maybe like fives. Oops, that's not by fives. Something like that. Yeah, it'll go a little above. So 0 to 1, it's at 3. 2 to 3 is at 13, so something like around here. And 4 to 5, bless you, is way up at 21, so I'm going to be like off my, something like that. Okay, and 6 to 7 is at 11, and 8 to 9 is at 2. Again, what's the distribution of this data, Sam? Symmetric. So when we can see that it's symmetrically distributed, which measure of center would we want to use to describe this data? When it is symmetric distribution, which measure of center do we want to use? Miles? Mean. Good. So the measure of center would be mean, and then which measure of variation would we want to use? Luke? Mad. These always go together. So once you know you are going to use mean, you also want to use mad with that to describe variation. That's our measure of variation. Okay? This one says the dot plot shows the average number of hours students in a class sleep each night. It says describe the center and the variation of the data set. The first step is to always look at the distribution of the data. How would we describe the shape of this distribution? You guys raise your hand, please. Thank you for raising your hand. It is skewed left. Our highest point is here, and we have a tail going to the left. So this is skewed, meaning which measures of center and variation would we want to use? Will, what would we want to use? Good. Good. Median and inner quartile range. Now, it's not a box and whisker plot. If it were, it would be really, we haven't talked about that. That's tomorrow's lesson. We're going to use a dot plot to describe this. Okay, remember, to find the median, we have to, I think the easiest way to do this is to line up the values of data. So I'm going to do this down below. And a lower half. So when we get that 8.5 as our median, then we find the median of the upper half. Now I'm going to cross out. And then 9 is our Q3. Remember this? And then we do the same thing in the lower range. And we end up with 7.5 is our Q3 or Q1. And we found was 8.5 once we figured out that I missed a number. And what's the inner quartile range? 1.5. 9 minus 7.5. We take Q3 minus Q1. So we do 9 minus 7.5. Our inner quartile range is 1.5. Okay? Obviously, being super careful and neat helps, and not missing a number because it'll throw you off, as we saw. Each have 16 envelopes with money inside. So it's baskets of envelopes of money. For what? I don't know. Here we go. I know. So it says, how much does a typical envelope in each basket contain? We'll put that up later. Now, what kind of question is this? You're right. This is a statistical question. Because is there one right answer? No. But you can answer statistically by finding information about each of these baskets and answering in a way that uses statistics. If this data was skewed to the left or to the right, which data piece would you want to use to describe the typical envelope? If this data was skewed left or right, what data piece would be a good measurement of a typical envelope? Tate? The median. Good. And the inner quartile range to describe the variation. If it was symmetrical for one of the baskets, which data would you want to use? Anna? The mean and the mad, right? I'm not going to do it just because it's going to be a lot of adding. And then from there, it says, why might a person want to pick from B rather than A? Voila, here's the dot plots. Basket A is plotted on the left. Basket B is plotted on the right. Okay? I think these are fairly symmetrical, do you think? I would say so. We would probably want to use the mean for each of these, add them all up, divide by 16. Why would a person want to pick from basket B, if you're looking at this? Why would a person want to pick from B rather than A? Liam, what do you think?
There's more greater numbers than B than A.
Okay, good. The data is concentrated between 40 and 60, so the likelihood of you picking 40 to 60 is higher. What would you expect to see in the measure of variation for basket B? Would it be a large variation measure or a small? Miles? Small. It's not very spread out. It's very concentrated in the middle, so it would be smart to pick from that one because you'd be more likely to get some money. Now, which one could you pick the most money from? If you were going to pick one, which one would you want to pick from to try to get the biggest amount? Yeah. A has $100. There's no $100 in basket B, but you're more likely to get more money on one pick in basket B.
What if you get nothing?
Or nothing, that's true. High risk, high reward. All right, so that's what we're asking in this section, is just figuring out distribution, measures of center, variation, and how to discuss data.